Agentic AI is a big topic right now. Everyone's talking about how AI systems can autonomously search, decide, and act to solve real-world problems. In this tutorial, I'll show you how to build an agentic AI system using CrewAI and Ollama. We'll create an AI research assistant that automatically finds websites related to a topic you give it, and we are going to do this all completely for free. If you haven't got Ollama installed yet, watch my AI Engineering for Beginners video where we go over how to install it there. Now, let's get started. So with your VS Code open, let's start getting our project all set up. So the first thing we'll do is create a virtual environment, which is done with Python -m venv, and we will name it venv. So this will create our own environment for this project, where our packages and dependencies that we install on this will only be available for this application. And the reason why you want to do that is different projects you work on might have different versions of dependencies, and you want to make sure the project has the specific version for it. So with that created, we now need to activate it, and you do have venv scripts activate. And now that we have this, we're going to install 3 packages. So we'll do pip install, and we'll do CrewAI square bracket tools square bracket, then we'll do space, and we'll install Ollama. And then for researching the topic to find websites, we're going to use the duckduckgo-search package, as this is the only search engine API that I've found that you can use for free, while all the other ones require creating an account for an API key or paying for one. So we will have these 3 packages installed for this. CrewAI comes with a lot of dependencies, so this might take quite a few minutes, so I'll come back when that's done. Okay, so it's now all installed. The next thing we need to do is download the Ollama model that we'll be using for this. Now, one thing I should note, because we're doing everything entirely for free, we'll also be using free models which are smaller in size and less powerful than the paid ones that you see from OpenAI, Anthropic, and all those. So I will say from now that using these models they don't work too well with CrewAI, and I had a lot of difficulty finding a model which worked. I had to keep downloading them, try them, they'd fail, they wouldn't work correctly. So this is mostly for demonstration purposes and just to get you started learning about agentic AI. For real world applications, you would use either the APIs of OpenAI, Anthropic, or the cloud services, or you would host it on a server that has a very beefy GPU. With that said, we'll be downloading Llama 3.2 and with 1 billion parameters. So we will enter Ollama pool, and this is Llama 3.2:1b, and we do that. Okay, there we go, it's now downloaded. So let's get started with this. First thing we'll do, we will create an app.py Python file. So I guess before we properly get started, I should explain what CrewAI is and how it works. So with CrewAI, you have a bunch of different components which are combined together into what's known as a crew. Now the components of the crew are the agents, tasks, and tools. So with agents, you can think of these as like people within a team. Within your team you have a bunch of different people, and each person will have their own different role and their own strengths that they have. So within CrewAI and your crew, you create an agent who specializes in a certain task. Next, you have the tasks. These are the individual pieces of work that are going to be done. So you create a task, and then you assign an agent to the task. So this agent will complete this task. And finally, you have tools. Tools are pieces of Python code that you write yourself. So custom Python code which the agent will use to complete its task. So you have an agent, you give it a tool, and it uses that tool to complete the task. So within what we are doing, we're going to have an agent who specializes in researching. We're going to have a task which is about researching a certain topic that we want to find out more about. And then we're going to have our search engine tool that the agent is going to use to find URLs about this topic. So with that out of the way, let's get started into writing some code. So there's quite a lot that we need to import. So let's start off with from CrewAI, we will import LLM, agent, crew, and task. So we've got these imported. We now need to import from CrewAI.project, import crew base, agent, crew, and task. Now from CrewAI.tools, import base tool. So that's all we need to import from CrewAI. But now we have our duckduckgo-search. We import ddgs. And what we also need to import is from Pydantic, import base model and field. So we're going to start off with this for now, but you'll see how everything works as we go along. So to begin with, let's set up what LLM we are using. So we'll create a variable LLM is equal to LLM, and within here we're going to specify that we are using Ollama, the Llama 3 model from Ollama for this, because by default it defaults to using Open API. So we need to specify ourselves that we are using Ollama. So for that we do model is equal to Ollama, then slash llama 3.2:1b. And what we also need to do is specify whereabouts what URL is used to access this. So when you install Ollama, there's actually an API within it which you are accessing to access these models, and that is on a port on your device. So we'll go base URL is http://localhost, and the default port is 11434. So this LLM object is now all set up for us to access it. Next thing we're going to do is actually create the tool for accessing DuckDuckGo. But before we do that, we should probably talk about how the LLM and agent actually knows what tools we have. So we create tools and we have descriptions for them. These descriptions are passed to the LLM so it knows, okay, I have this tool, it has this name, it has this description, so it knows what this tool is used for, and then also we have a schema for it which just specifies how to use it. So we'll start off with the schema. So class, we'll call it search engine schema, and this is using base model. So this is from Pydantic. What we now have to do is give a description here, because when the LLM is going to see this description to know what it does. So what this class is, it's the input for the search engine, and it's going to have one property which is query. So this is the query that we're going to be doing for the Google search. Now we need to use typing and Pydantic to further specify what exactly this query is. So this query is a string, and we're going to use the Pydantic field and do 3 dots here, then description. Now this description, the query to be submitted to the search engine. So the LLM will see this description right here when it's looking at what data it needs to pass to the tool. So this is the schema complete. Now it's for actually creating the tool. So we'll do class search engine, and this is base tool. So this is a CrewAI class. So when you have a class which uses this as the base, it knows how to actually use it. So there are a few properties we also need to give it for describing it. First is name, which will give it a string, and we can call it search engine. Now we also need to give it a description, which is also string, and we will call it so I guess this is describing what the tool is used for and what you're expecting from it. So we'll say the description is submit a query to the search engine and receive a list of URLs. And the last property we need to put is args schema, which is equal to the search engine schema we created. So now it's actually creating the function for running the code. So for this, create a function def_run. It must be called that because that's what CrewAI calls when trying to run this tool. We then first do self, and then the properties for this function are what we specify in the schema. So we have to do query and make it a string. And for this, we are going to return a list of strings. Well, I forgot to import this from typing. So now the top here, from typing import list. So within this function, we're going to do with duckduckgo-search, and we'll do as ddgs. We're going to do ddgs.text, and we'll pass our query. Now let's do max results. Let's have it pass a maximum of 10 URLs back to us. And then with this, we now need to turn it into a list, and this is our results. So what we'll do now is we want to make sure this has worked as expected. So we'll do if results. What we're going to do is return a list, and we're going to go through all the results, grab the URL from it, and create a list of URLs. So let's do for result in results, we will grab result and the href from it. So that if we have results, we're going to return all the URLs we got, and if it did fail, we'll just return an empty list. So that is everything for the tool. Now we need to actually start making the crew, the agents, and the tasks. So there's two ways that CrewAI have set up for creating agents and tasks. One is through YAML descriptions of the agent's task, and the other is through actual Python class. We're going to do the YAML way because that's the way they recommend. So to get started with that, we need to create a new folder which we'll call config. We will then create a agents.yaml, and then we create a tasks.yaml. So for this, we are only going to have one agent. So we are going to call it the research agent. This research agent, their role is that they are a researcher. This agent has a goal, and their goal is to find websites relating to a given topic. And then finally, they have a backstory. And this agent's backstory is that, well, you write this in the perspective of you telling them what they are. So you are an expert at finding websites that are relevant to a given topic. And we can probably keep it as that. So for tasks, we will also only have one task, and this is going to be our research task, and we need to give it a description which describes what this task does, or what should happen in this task. What I should say is the description is telling the agent what it needs to do to perform this task. So we'll say, use the search engine tool to find URLs relating to the topic, and what we're going to do is curly brace topic. We'll put single quotes around it. So when we run this, we're going to have a variable which has the value of the topic we're going to actually be researching. So we're going to do that, and we'll let them know that these links will later be used for further research. So that's just letting it know. The only thing we want is for it to find URLs for us. Now what we also need to do is specify what the output should look like. So expected output, and we'll say a list of URLs. So that is all we want. We just want the list of URLs. We don't want anything else, any descriptions or anything else. And what we now need to do is specify which agent is going to be working on this. So we do agent, and this is going to be our research agent. So we've got our agents created, and we have our tasks created. Now we need to actually build up our crew. So back to app.py, we're going to use the decorator crew base, and that is going to go over our class research crew. So we'll give this a description, a crew for conducting research on a given topic. So we now need to create our agent. So similar thing, decorator for agent, and we create the function def research agent self and return agent. So we're returning an agent, and first we need to use this YAML configuration within here. So config is equal to self.agent config research agent. So within the crew base, I'm pretty sure it's set up so it knows to go to the config directory, search for the agents.yaml, and then it's saved it in here. Actually, I should probably check that now. Agent config, oh yep, so we can see right here, agents config, it's going to config agents.yaml. So that's how that works. So the crew base already has this property set up. Now we're just retrieving the research agent from it. So we've got the research agent. We now specify what tools it's going to use. It's going to use the search engine tool, and you can just create a new instance like that. All I need to do, tools is equal to that. We now need to specify what LLM is this agent going to use. What you can do is use a variety of different LLMs, because each LLM has its strengths and weaknesses. So you might have an LLM, you might have an agent doing one thing where an LLM, certain LLM's better for that, then a different agent where a different LLM's better for that. But in our case, we're just going to use the same LLM just for demonstration purposes so we get something working. So LLM is equal to the LLM object we created earlier. And now I'm going to do verbose equals true. When you do verbose equals true, it prints out what the LLM is thinking and what it's doing. So it's good for our cases for demonstration purposes. So we have our agent created. Now we need to do task def research task, and we do self, and once again return task. And with this is return task, and similar thing, we need to do config is equal to self.tasks config, and this will be research task, and that should be all that we need to do. Something I should mention, so we've got, within the YAML, we've got these descriptions like this. If we weren't doing YAML, we would go into here and do description, and then expected output, and all that. The reason I find for doing the YAML way is being able to just do this. When you do the curly brace variable injection thing within here, you don't need to handle it. CrewAI fully handles it for you. While if you were to do it the Python class way, which would be this, you would have to manually do the string format and all that yourself. So we'll keep it like this with YAML. So we've got our agent and we've got our task. Now it's the actual crew that we need to create. So at crew, and we'll do def crew. This is self and returns crew. So we'll give this a description. So now we need to return the crew, and then here we need to specify what agents are within this crew. We should create an agent object, but not use it within the crew. You might have multiple crews you're defining. So that said, agent is equal to agents is equal to self.agent. So one thing that these decorators do is I'm pretty sure, okay, I was thinking it would add it to it, but maybe not. So we can do self.agents, where these agents are automatically added to this. And then same thing, tasks is equal to self.tasks. Now the only thing that we need to do is also set this voice to true, just so we can see exactly what's happening. So we've basically got everything set up now. It's now about actually running this. So what we'll do, let's do topic is equal to input, enter a topic to research. So we've now got our topic. We now need a way to pass this topic to CrewAI. So we're going to create a dictionary called inputs, and this will have a key of topic. Oop, I should do this way, topic. And it's going to have the value of what's in our topic variable. So we've got our inputs. We now need to pass it to CrewAI. Well, I guess at this point it's a matter of running it. So let's do result is equal to research crew. So we're going to run that, and then from that we can go to our crew, run that, and then we do kickoff, which is actually running it, and we pass our inputs to it. Inputs is equal to inputs. So when this runs, the kickoff is going to return the last task that ran, the output of the last task which ran, which will go in here, and from here it should hopefully be the list of URLs. And then we'll go to the bottom here and do print result. So hopefully I've done it all correctly and this runs first try, but that should be all that's needed to run CrewAI, where we've got agents, task, tools, and have something run from start to finish like that. So let's give it a try. We'll go Python app.py. So let's try, I want to learn more about CrewAI. So I'm going to say this before I press enter. There's a good chance that we're going to get some weird outputs. It's not going to run properly. Maybe it will just fail. And that's because of the LLM we're using. Because I'm running this on my own computer, I can't run a super powerful LLM like the providers such as OpenAI and Anthropic can run on their servers. So I've had to use a low-powered model, and it's very possible that it doesn't work. But with that saying, I'm going to press enter and hope for the best. So straight away we can see agent researcher task, use the search engine tool to find URLs relating to the topic. I want to learn more about CrewAI. So we saw here we put the curly brace topic. So what we wrote here got injected into there, and it's saying these links will later be used for further research. Okay, so let's take a look at what has happened. So one problem is it doesn't show literally everything that gets sent to the LLM. So under the hood, it was given all the instructions from the task and the agent and what tools it has available. And we can see here, it tried to do the action, use the Google search engine. And let's see, so use tool name, search engine, tool arguments, query description. Okay, I had that access to it. So I guess in our description of the tool, if I can scroll up to it, maybe not. Well, we never mentioned what search engine it's using. Although it's using DuckDuckGo, we never actually explicitly said it, so it's assuming it's Google, which is interesting, but that shouldn't actually make a difference. So, okay, so below that we can see the agent researcher has a thought. You need to consider how search engines work before finding URLs for your topic. So using the Google search engine, it has these, it knows what arguments it needs to provide it, and the tool input, well, it gave it nothing, which wasn't very good. It was meant to give something relating to what our topic was. So it's now saying tool output, I encountered an error. Action, use the Google search engine. So it's now going through again, tool output, it's got all the information about how to actually use the search engine tool. And then hopefully, nope, we've got some more errors here still. Nope, still gave a blank input for it. It might continuously do that, which is a bit annoying. Oh, there we go. Use the Google search engine. Or it made a mistake there. It thinks the tool is called use the Google search engine, but it gave it the correct query input this time. But because it used the wrong tool name, there is no tool called that, it can't run, which is a shame. It was so close to getting it right this time. Okay, now it's starting to mess up. It's trying to find the tool. The user wants to know more about blah 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 blah. Yeah, so if we were using like an OpenAI model, Anthropic model, we would find this working first try basically. Sometimes they fail and do the wrong thing, but they quickly fix themselves. But that doesn't seem to be the case with this. Or maybe it did work. Okay, no, it seems to be failing. It is now just trying absolutely any possible thing to get it to work. Okay, well, it finished running and it did not do what we wanted. The final answer it gave us was not a list of URLs. It's your final answer must be the great and the most complete as possible. It must be outcome described. Note by the AI system, blah blah blah. So I'm going to try running this one more time, see if we get a good output, and hopefully we do. So I'll run it again, and maybe I'll just do large language models. So no complicated statement like I want to learn more about CrewAI. We'll just put in a simple thing like this, and maybe it'll work. Okay, so well, after trying this again with large language models, it ended up giving me a list of programming languages. Not sure how it made that leap, but apparently it did. So I'm not going to continue trying this anymore. Like it's very hit and miss with this with the smaller large language models. Hopefully you had better luck than I did. But anyway, I hope this video gave you a good overview as to what Agentic AI is all about, what it looks like developing for it, and hopefully being able to run it and seeing actual results. So if you like this video, make sure to like and subscribe.